Alright, now we're moving on to 10.3, arcs and chords. We've had this before. What is it? An arc is a distance around the circumference of a circle or circles. Chord, that is a line that will go to two sides of the circle but not through the center. And as you can see from the theorems that we've got here, examples, it's telling you that they are the same length. Okay, so again, if they tell you it's congruent, then they must be the same length. FG is the same as JH, or look for the notation. Okay, if you notice the notation on QR and ST, so that they are congruent, you can put them together. As you can see in this part here, it's writing proofs, and the reason why it's writing proofs, but most of the time it's going to be algebra. So now we're looking at example 1. How do you use it in real life? Embroidery hoops, if you're into that sort of thing. Two things it will tell you in this direction. First of all, it tells you here that they are congruent, and also in the notation in the photograph also tells you the congruent. It tells you that one of them is 60. How big is the other? Well, if one is 60 and they're congruent, then the other one has to be 60 also. And as I said at the beginning, this is example 2. Obviously in the previous example it was by notation, this time also by notation, that these are congruent, and it tells you that the chords are congruent. So now in this time though, we're using algebra. Okay, they must equal each other, put them to equal each other, solve for the value of x, and then guess what? Plug it back in again. Okay, so make sure you plug it back in to make sure, and plug it back into both of them. If you get the same answer, your algebra is correct. If you don't get the same answer, you've done something wrong. It's a great and simple check for you. So let's have a look at the examples. Let's have a look at out of examples 1 and 2. Question number 1. Okay, you are told that this angle here is 93 degrees, which means that ST must also be 93 degrees. What else does it tell you? Well, it tells you that both of these are congruent by the notation. Well, if ST is 93 degrees, SR must also be 93 degrees. Now let's have a look at question number 3. Both of them, AB and CD, are 127 degrees, so that means that you've got 3x plus 6 must equal 5x. Okay, so 6x, just 6 is equal to 2x. So x equals 3, plug it back in again. 3 times 5 will give you 15. 3 times 3 is 9, plus 6 will also give you 15. You know your working is correct. Okay, so as you can see from the theorems here, if AB is the diameter because it goes through C, then XY, if it bisects it, and look for notation, so it must be a right angle. If it bisects, then it must be congruent. So as you can see, that they'll make them congruent. And again, you know what the scenario is going to be. The chances are it's going to be some sort of either algebraic equation, or it could actually be a Pythagoras question. So let's have a look at what you've got. All right, you know that QS is the radius, PR is the chord, and you will notice that the chord bisects at right angles. So by theorem 10.3, this must be congruent to that. Well, if they're congruent, and what you're trying to find is the arc of QR, well, that's 49, but in this case you want PR. Well, PR is the length of the chord. Well, if from RT is 6, from TP must also be 6. So you've got 2 times 6, which will give you a distance of 12. All right, so let's take it one step further, which is a real world example 4. Okay, it's taking part of the stained glass window and in superimposing it as a problem on its own. Okay, what's it told you? It's telling you that JK is the radius, the same as JH is. KM is a chord and it bisects. It's then going to give you part of the information. So from there, as you can see, I did say a few minutes ago, Pythagoras is going to come into play. That will give you the information that you need to answer the question. Okay, so we're going to do question 4 and question 5 together. Well, question 4 is JL, which is this distance from here to here. Okay, but what do we do know from the information? From J through L all the way to K is 134. So obviously JL is half that distance, so it's going to be 134 divided by 2, which is going to give you 67. All right, PQ is a little bit different. So let's have a look at what you've got. I'm going to take this section here. So let's have a look at this triangle that we know. Okay, what do we know? We know that this is a right angle. We also know that JK is 10. So here's Q, here's K. So if JK is 10, QK will be 5. What else do we know? Well, from P to M, which is the radius, is 6. And P to K, so here's P, P to K is also 6. And we want this distance here, I'm going to call it X. Okay, so this is Pythagoras, so in theory, so X is going to equal the square root of 6 squared minus 5 squared. So X is going to give you, and again to the nearest hundredth will be 3.32. And here's example 5, chords that are equidistant. In other words, they are the same length. So using that information, you know that these two guys are congruent, so it's just a case of plugging it in. So your 5x would equal your 3x plus 4. Solve for x, plug it back in again. But again, in the question, they'll only do it to one of them. I would actually plug it into the other. 3 times 2 is 6, plus your 4, it'll give you 10. At least it proves the fact that 2 times 5 is also 10. They equal each other, so your algebra is correct. So plug it back into both. And here's question number 6, which is example 5. What does it tell you? That these two guys are both 5, so they both equal each other. All right. So both of the segments must equal each other. So you've just got a simple algebraic equation, which is 4x plus 1 equals 9. And it's just asking you to solve for x. Subtract 1 from both sides, so 4x equals 8. Divide through by 4, x equals 2.